Hi, my name is Emma,
And my name is Lily.
and this is our Unit 5 Quadratic Functions review video.
Our first standard is solving quadratic equations with real coefficients that have complex solutions. This is the quadratic formula. A is located in front of x squared, b is located in front of x, and c is the number alone. These are a few examples that we have. Our first example is x squared plus 3x plus 6.
A would be 1, B is 3, and C is 6. When you plug those numbers into the formula, it gives us x equals negative 3 plus or minus the square root of 3 squared minus 4 times 6 times 1 over 2 times 1. You can simplify that down to x equals negative 3 plus or minus the square root of negative 15 over 2. And now since we know that the square root of negative 15 isn't possible, that gives us these two equations as our answers. X equals negative 3 minus I square root of 15 over 2, and x equals negative 3 plus I square root of 15 over 2.
Our second example is negative x squared plus 4x minus 9.
For this equation, A is negative 1, B is 4, and C is 9. When you plug these numbers into the equation, x equals 1 plus or minus 4 squared minus 4 times negative 9 times negative 1 over 2 times negative 1. This simplified gives us x equals 1 plus or minus the square root of negative 20 over 2, which leads us to the final answer of x equals 1 minus 2i square root of 5 over negative 2, and x equals 1 plus 2i square root of 5 over 2.
Our second standard is interpreting expressions that represent a quantity in terms of its context. Interpreting parts of an expression such as terms, factors, and coefficients. Interpreting complicated expressions by viewing one or more of the parts as a single entity.
Some of the vocab for this standard is term, which is either a single number or variable, or numbers and variables multiplied together. Terms are separated by plus or minus signs.
Our second
Vocab word
is factors. Numbers you can multiply together to get another number or an expression.
Our third vocab word is coefficient, which is a number used to multiply a variable, which is the number next to the variable. An example for this standard would be identifying how many terms are in the expression 5x squared plus 2x. There are two terms in this expression because 5x squared is one term, and that's separated from 2x by the plus sign. The difference between 5x squared plus 2x and 5x squared plus 1 times 2x minus 3 is that the first one has only two terms, while the second one has four terms, but is two factors, which makes it a binomial expression rather than just a regular expression.
Our third standard is using the structure of an expression to identify ways to rewrite it. Convert this equation to standard form by multiplying. Y equals 2 times x plus 3 squared minus 22.
You start by multiplying x plus 3 and x plus 3, which gives you x squared plus 6x plus 9. You keep that in the parentheses, and then you distribute the 2 to give us 2x squared plus 12x plus 18 minus the 22. Then you simplify, and it ends up being y equals 2x squared plus 12x minus 4.
Our next standard is to choose and produce an equivalent form of an expression to reveal and explain properties of the quantity represented by the expression. Factor a quadratic expression to reveal the zeros of the function it defines. Complete the square in a quadratic expression to reveal the maximum or minimum value of the function it defines.
How to solve by factoring. First, make sure the equation is set to 0. Second, factor as before. And third, set each factor equal to 0 and solve each piece.
Completing the square. First rearrange so it only has terms with x on one side. B, take the variable b from the equation and divide by 2 and then square it. C, add that number on both sides. D, simplify, and E, rearrange to where y is alone.
For the example of solving by factoring, our equation is x squared plus 7x plus 10 equals 0. Two factors of 10 that equals 7 are 5 and 2, so you do x plus 5 times x plus 2 equals 0. You set each of these equal to 0 and solve for each piece, leaving us with x equals negative 5 and x equals negative 2. For the completing the square, we're going to change from standard to vertex form, and so we're going to take the 32 and subtract it from both sides, take 12 divided by 2 and square it to complete the square for the x, and then you have to add 36 to the second side to keep it equal. You simplify to where it's x plus 6 squared equals y plus 4, and then you move the 4 over, and it's actually supposed to be negative 4, but I'll change that, and so, sorry, fixed it to where it's negative 4. And then for our next standard, it just is telling us why we would want standard form or vertex form, and you would want standard form to find the y-intercept, and you would want vertex form to find the maximum or minimum. And the minimum would be negative 6 minus 4, because it's x minus h in parentheses, so since it's plus 6, it's actually negative 6. And it opens up because it's not negative in the very front, so it would be a minimum. Oh, for our next standard, we're creating equations and inequalities in one variable and then using them to solve problems. Include equations arising from quadratic functions. So we're going to graph x is less than 4.
Okay, so the reason the line is dashed is because there's no line underneath the inequality sign. And then you would shade on the left side of the line since it's less than.
If it was y is less than 4, then the line would be flipped 90 degrees and changed so that it's up or down, side to side rather than up or down. And you have to think about the dashed versus solid line and which side to shade it on to get these types of equations right. For our next standard, you create equations in 2 or more variables to represent relationships between quantities, or you graph equations on coordinate axes with labels and scales. So we're going to graph the equality x is greater than or x is less than or equal to x squared plus 1x minus 2. We can already figure out that this inequality is going to be a solid line because it is less than or equal to the equation. And then, so you're going to type x squared plus 1x minus 2 into your calculator, and you're going to get the table of negative 3, 4, negative 2, 0, negative 1, negative 2, 0, negative 2, 1, 0, and 2, 4. Notice that in the middle it's negative 1, negative 2, and 0, negative 2. That's because there's a number in between 0 and negative 1 that is actually the vertex for this equation. But I just went in steps of 1 and not half or whatever it was. So the vertex isn't included in this table. We also know that this graph is going to open up because there's no negative in front of the x. So the graph for this equation looks like this, and as you can see, the vertex is below negative 2 and in between 0 and negative 1. The points are 1, 0, 2, 4, negative 1, negative 2, negative 2, 0, negative 3, 4. And it's also the solid line, as we stated before. And a way to figure out whether you need to shade inside the parabola or outside the parabola is finding a point like 0, 0 and plugging it in for x and y. So when you plug in 0, 0 for x and y, it ends up being 0 squared plus 1 times 0 minus 2. And then when you plug it in for y, it's just 0. So that would be 0 is less than or equal to negative 2, which is not true. And that's why you would shade the parabola on the outside. because that when you plug those numbers in, it's not true. But when it is true, you would shade it on the inside. That's all. Thank you for watching our review video, and I hope you had a great time.